As sand leaks out of a hole in a container, it forms a cone, a conical pile whose altitude is always the same as its radius. Okay, I'm gonna just start writing stuff down, okay? May not get me very far, but we have a cone, okay, good to know. Maybe we'll be dealing with volume. Maybe we'll be dealing with surface area. By the way, seldom do you deal with the surface area of a cone. So let's just go ahead and deal with the volume of a cone. And when you read, you'll realize that. 1/3 pi r squared times h, that's the volume of a cone. And the altitude, height, is always the same as its radius. So as this yeah, right, sand. As the sand leaks out, you're gonna have a cone. Draw it if you want to or not, doesn't matter. You're gonna have a cone whose height is always the same as its radius. So this height and this radius are always going to be the same. It just consistently works out that way within this context of how the sand is falling. All right, let's keep moving. If the height of the pile is increasing at a rate, they gave us dH dt, 6 inches per minute. Find the rate at which the sand is leaking out. Let's clarify. That's asking for the rate of change of the volume. If I say how much sand, you would answer with cubic inches, cubic feet, cubic something volume. Gallons, which is kind of an odd way to measure it, but you could. So a measurement of volume of sand, that's what they're wanting. When the altitude, also known as the height and altitude are the same word. So I'm going to write that down because it comes in handy. Altitude is another word for height. And so when you see height here and you see altitude, they are the same thing. Just writing it down so we'll have a visual, and we'll also realize that when I say height and altitude, I'm talking about the same thing. Just throwing that out there. Okay, the altitude, the height, is 10 inches. So let's keep going with this idea, and let's start taking a derivative. But you know what? As we get into this a little bit deeper, you're going to realize I don't want to take the derivative. You're going to rebel against me and not take a derivative, and here's why. Product rule. Do you want to do the product rule? You may want to, and that'd be fantastic, but let's avoid the product rule, okay? Here's why. I know enough information, h equals r, to take one of the variables out and put the other one in its place and avoid the product rule. So before I even take a derivative, let's simplify, and here's what we're going to do. They tell us the rate of change of the height. They tell us the height. So let's keep height and replace radius with height. Nowhere in here do they talk about radius. So we are going to say r squared is really h squared, and then times h again. So you could skip that step and call it 1/3 pi h cubed. Now we don't have to do the product rule. And you could if you wanted to, but this is easier, trust me. So the rate of change of the volume, that would be dV dt. The derivative of 1/3 pi h cubed, 1/3 times 3 is 1 pi h squared, dH dt. We can do this one in our head, actually, if we don't multiply by pi. So the rate of change of the volume is pi times height times 6. That's 100 times 6. That would be 600 pi. Okay, that is correct. I'll figure out the decimal for it in just a minute. But in the meantime, let's get the units. We are dealing with volume. Volume is, in this context, cubic inches per minute. There we go. This is correct. If you want to go a little further, you could by finding out what 600 times pi is, and that would be 1,884.956 cubic inches per minute when the height and the radius are 10.